Girls, today we're going to go through the final part of this topic where we're going to look at comparing and contrasting electrochemical and electrolytic cells, and I'm going to briefly go over the requirements for this assessment. So what do you actually need to know and what do you need to be able to do? So first off, the compare and contrast. So compare and contrast, just to be really clear about what we're looking for, is to consider what is the same between the two types of cells and what is different. So starting off with the things that are the same, we've got some fairly obvious things going on. First off, in both cells, we've got oxidation occurring at the anode. We also have reduction occurring at the cathode and electrons flowing from the anode to the cathode. And this occurs in every type of electrochemical or electrolytic cell. Now, however, we get to the things that are slightly different. So first up, in an electrochemical cell, we have a positive E0 value for the cell, and the reaction is spontaneous. In an electrolytic cell, the E0 is negative, and the reaction is non-spontaneous. In an electrochemical cell, we need to have a salt bridge or some medium for the electrons to flow from the half equation that's occurring at the anode to the half reaction that's occurring at the cathode. Whereas in an electrolytic cell, we need an external power supply, otherwise the reaction won't happen. Now we get to the slightly more complicated bit, and this is the bit that we've kind of talked around but haven't necessarily gone into in enough detail, and this is the bit where I expect you'll probably have a few questions for me. So, in an electrochemical cell, the strongest oxidant, which is the weakest reductant, the thing with the most positive E0 value, is being reduced. In an electrolytic cell, the thing that is the strongest oxidant, and therefore the weakest reductant, and the thing with the most positive E0 value, is actually being oxidized. Similarly, in an electrochemical cell, the strongest reductant, weakest oxidant, is being oxidized. That's the thing with the most negative E0 value. Whereas in an electrolytic cell, the strongest reductant, which is the weakest oxidant, and the most negative E0 value, is actually being reduced. So that's where the two really become quite distinctly different. In an electrochemical cell, our oxidant is being reduced and our reductant is being oxidized, and that's exactly what you would expect to see. However, in an electrolytic cell, the reverse is happening. So our stronger oxidant, or our weaker reductant, I should say, is the one that's being oxidized, and the weaker oxidant is being reduced. That's why we require a power supply in an electrolytic cell, because we're forcing those electrons to move in a way that is against their natural tendency. Okay, so that's the basic compare and contrast between the two cells. Now, the assessment requires a number of fairly fundamental skills, and ones that you should be fairly confident with by now, I hope. So, you need to be able to make observations of redox reactions and link those observations to reactants and products. In other words, what colour was the reactant, what colour was the product, and therefore what reaction has occurred. You need to be able to identify which species has been oxidized and which species has been reduced, considering both the electrons being gained or lost and the oxidation numbers increasing or decreasing. You need to be able to write both balanced half and full redox reactions or equations. You should be able to use the standard cell notation, that's the one with like the single lines and the double lines, to represent an electrochemical cell. You should be able to calculate cell voltages using standard reduction potentials and use these to determine whether or not a reaction is spontaneous. And finally, you should be able to compare and contrast the processes associated with electrolytic and electrochemical cells. Now, all of this takes place in the context of having some demonstrations to observe, and you get provided with your species colours and states, and with the standard reduction potentials. So you do not need to memorize either of those. We'll go through this in more detail in class and we will work through some practice examples, but this is the basic stuff that you need to know. So what I want you to do is to think through that, tick off the things that you can do, and then think about what you actually need to be focusing on for your learning and preparation for the assessment. Thanks very much, girls. I'll see you soon.